Hello guys, today we are going to solve a problem from LeetCode 739, daily temperatures.
Oh, see, look at this, what happened? Look at this, what
At
happened?
least I have some.
Look at this.
Oh, it's so cold. It's so cold.
In fact, it is very cold outside and it was snowing a lot also yesterday, so I thought this is a good problem to solve for today. Let's see this question. Given an array of integers, temperatures represent the daily temperatures. Return an array answer such that answer I is the number of days you have to wait after ith day to get a warmer temperature. If there is no future day for which this is possible, keep answer I equal to 0 instead. So if you see this example 1, there is an array and in which temperatures are given in Fahrenheit, and we have to return for each day, right? How many days we have to wait for a warmer day to come and we can go out. If you see this, we can take a very simple approach here. From 73 to 74, it's just one day, right? We just have to wait for one day, right? So the next greater temperature day is just tomorrow. That's why we are going to return one day here, okay? For 74, it is 75. That's why 1 again. For 75, if you see, there is even temperature is going down, 71, 69, 72 and then 76. So you have to wait for 4 days, right? And then you will be able to go out, okay? If we want to take a very naive approach and solve this problem, then what we can do, we can actually run 2 for loops, right? And for each temperature, we have to find the next greater element and deduct the number of days, like, so we can actually take the index, right? Then it will be a n square time complexity, right? And we want to do better than that. To solve such type of problems where we have to find the next greater element, there is a very beautiful data structure which is called monotonic stack. So let's learn that monotonic stack first and then solve this problem, okay? Let's take this array, let's build our monotonic stack. Monotonic stacks are nothing but stacks, but they maintain the elements in a particular order. So depending on the order, we can call a stack as a monotonically increasing stack or monotonically decreasing stack, okay? So to solve this problem, particularly this problem, we are going to build a monotonically decreasing stack. When we are looking for a greater element, we have to build a monotonically decreasing stack. When we are looking for a smaller element, we are going to build a monotonically increasing stack, okay? This is the input, I'll say input, okay, and our stack. So let's say I'll call this monotonically decreasing stack, okay? Now stack does not have any element and we are looking at 73 right now. So because there is no element, we'll push the element into the stack, okay? Now let's say we are now considering 74, okay? We are looking at 74 right now and I'm going to push this 74 onto this stack, okay? As I mentioned that we are going to create a monotonically decreasing stack. So what it means is, like, when you look at the stack from bottom to up, okay, then the elements in the stack should be in the decreasing order, okay? So let's say if I'll put this 74, let's say for example I'll push this 74 into this stack, okay? When I look at this stack from bottom up, okay, then it is monotonically increasing, it is becoming increasing, right? So right now when I push this stack on the front, 74 is my top element and 73 goes down, and from 73 to 74 when I'm looking at like this, right, when I'm looking at like this, then this is increasing in value, right? And we don't want that, okay? So what we'll do, we will remove this element, okay, and push this 74 to this stack so that we can maintain the monotonicity. So for 74, we'll kick this 73 out from the stack, okay, and we'll keep this 74. So I can say, so I'll say result, okay, for 73, I will say 74, and now when I push this 75 to my stack, right, then again I am violating the monotonicity, right? So in this case I'll again remove the 74 from here because it is less than my value. I'll push 75 here. So for 74 again I got next greater element is 75. Fine. Now I'm looking at 71. Okay, now let's look at 71, and for 71, if I push 71 here, actually I am not breaking any rule here. 71 is less than 75, so it can stay in my stack. So this is the property that I wanted to maintain here. So 71 will stay here without affecting the order of the elements present in this stack. Okay, now let's move on. Let's go to 69. Okay, 69 is smaller than 71, so we can push it, no problem. Okay, let's modify this result a little bit. Okay, so we'll say for 73 we got 74. Okay, for 74 we got 75. Okay, now when we are looking at 72, we are trying to insert 72 here, we are breaking the monotonicity, right? To keep the order intact, we have to remove this 2 element, right? So while the current number is greater than the top of the stack, we remove them. Okay, and for this number, so the result is actually for 69, the next greater number is 72. Okay, so because I'm going to remove 69. Okay, for 71 also the next greater number is 72. Now I'm looking at 76, and if I want to push this 76 into our stack again, we are again violating the constraint, right? So we'll pop this 72 out, right? For 72, next greater number is 76. Okay, now we are still violating the constraint, that's why we'll remove this 75 too. Okay, so we'll say for 75 also 76. Okay, so for 75 also it is this 76. You see 76, right? Now let's move on. Let's look at the 73. Okay, for 73, now when I want to push this 73 into our MDS, can I push it? Let's see, 73, and we are actually not violating any constraint here. We are still in the decreasing order, so we are fine here. Okay, if we look at this stack, 73 and 76 are there in this stack, which means for 73 and 76 we don't have any next greater number in this particular list. Okay, so for this one we don't have next greater number, right? Yeah, so we are not going to return this 74, 75, 76. These are actual temperatures. Rather, we want to return how many days we have to wait for that, right? So instead of putting the numbers, if we put the indexes, then we'll be able to solve this problem by deducting the indexes. Okay, yeah, so let's build a MDS with indexes. Okay, so we'll say MDS with index. Okay, fine. Now I'll bring this input again here. Okay, and let's build this. Okay, so I'll say MDS for 73. Let's push the 73. Okay, so it is 0. Fine. Now let's look at 74, and we are actually, when we try to put 74, we are breaking the monotonicity, so we'll pop this element out and we'll push the 74 index, right? So 1, right? As soon as we pop an element, right, that means we are actually breaking the monotonicity, and we have the result right there. Okay, so result is for 73, right? For 73 we have the index of 74, which element we are popping out, right? For 73 we popped out 74, so for this one index is 1, right? For 73 we popped 74, and that index is 1, and 73's index was 0, so 1 minus 0 equal to 1. Okay, now let's do like this. Now, okay, now MDS is 1 and 75, so now we are looking at 75, and 75's index is 2. When we are putting 75 into the MDS, we are again breaking the constraint, so we'll pop this 1 out, right? and we'll push the 2. Okay, so when we pop the element out for 74, we popped 2 and 1 equal to 1. Now look at 71. 71 is not violating the constraint, so we can safely keep 71. Its index is 3, so we'll put 3 here. Okay, in the same way 69 is not violating the order, so we'll put 69 also here. Okay, so now when we are considering 72, we are actually violating the constraint. As we saw here, 72 is actually pushing the 76 out, right? Index is 5, which is actually breaking the order. Index 4 and index 3 we are removing, and we are keeping only 5 and 2 for now. For 69, right? For 69, 4, so 5 minus 4 is 1. 4, 69, 1. Yeah, for 69, 1. Okay, so we remove this. For 71, 5 minus 3 equal to 2, so we'll remove this 3 also. Now we have 72 and 75 are in the MDS. Okay, now we'll push 76. So 72 is here, 75 is here, so now we'll push 76. Now take this 76 and let's try to push this here, whose index is actually 6, right? So when we push 76, we see that just before this, actually number 5, which is 72, is here, which is breaking the order again, so we'll push this guy out. So we'll say for 72, right? For 72 again, 6 minus 5 equal to 1. Okay, and we'll remove this 5. Okay, now we are still breaking the order. Okay, because number 2 is 75 and we have 76 now. Okay, we are still breaking the order, so we'll push this guy out, 75 from here. So for 75, 6 minus 2 equal to 4 days. Okay, and now finally we'll have the number 6 index in our MDS. Okay, and now we look at 73, and for 73, because we are not violating any order, okay, 73 is less than 76, so we'll push the number here. Okay, yeah, for these two we don't have any next number, so for them, as we already decided, we'll be returning 0, 0, 0. Okay, so while following this logic, what did we do? We made sure that the current number is always less than the top of the element. Okay, so less than the top of the stack. Okay, so if we follow this, if current number should be less than the top of the stack. If it is not less, then we were not pushing into the stack, rather we are popping the element until we find the correct place for that number, right? So the result, of course, result array should be the same size as of the input array, right? So I'll say int result array equal to new int the temperatures length. Now for int I equal to 0, I less than temperatures length, I plus plus. Okay, we wanted to use a stack, so we'll say stack integer. Okay, say monotonically decreasing stack, we decided to use new stack. Right. So what we did, if the stack is empty, we just pushed it, right? MDS is empty, So if the stack is empty, we just push the element, right? So we'll say mds dot push the element, okay, and let's say there is only one element and mds is empty. We push the element and we finally, after the for loop, we would have returned the result, right? And result, let's say I'm taking only one element, and for one element mds is empty and we pushed that element and finally we didn't do anything, we just return the result. Then we would still return element with 0, which is correct. Okay, fine. If it is not empty, if it is not empty, then what we want to do? So we want to maintain the decreasing order in the stack, right? So we'll say if the current element, which is temperatures I, current element is greater than the top of the stack, mds dot pick. If the current element is greater than the pick, right, then we want to remove that element, right, and we want to continue that element until we find its proper position. So we have to write a while loop here. Yeah, for sanity we also have to check, because this while loop can remove all the elements. So we'll say is not empty. Okay, we would like to pop all the elements, and yes, pop all the elements, and finally, because we are pushing the index, so we should be very careful here. We should compare with the peak element, not the index. Okay, once we pop, we'll get the index again, so we'll say index, and once we pop index, this is the index. For example, 73 will be popped here for 74. Yeah, the result should be 74 minus 73, right? So let's say 73 index is popped here, right? So what we have to do, we have to say result of what? Result of 73, which is index, right? So result of index equal to the current index, which is I, minus index. Okay, now after the while loop, we simply will push the current index, right? And if you look at this while loop, actually it is already checking the not empty case, so this if block we can completely remove. Okay, yeah, now let's see if it works. Run, accepted, cool. Let's test this with this guy also. Run, accepted. Let's test this with this guy also. Run, accepted, cool. So all accepted, and yeah, all accepted. Now let's submit this. Nice. So I don't know why it is 13.4%, but this is a O of n solution, guys, and this is how you can utilize a monotonic stack for solving this problem. Okay, I have seen that if we put the comment, it might run slow. So let me remove these comments and test it once. Let's see how does it look. I'll say submit. Oh, it did not increase. Okay, now let's see. Okay, let me put the comment back. Let's change this tag to dq, and this should be array dq, and let's run this again. Okay, and let's submit this again. Oh, somehow the queue implementation is faster than the stack implementation. I wanted to cover the monotonic queue implementation also, but I think this video is going to be very long, so I will cover that in another video. Till then, stay tuned and bye, take care, see you next time.